You will use this video to help you with the unit test review. So the video starts out with explaining each one of the problems, and at the end of the video, I have an answer key. I would like you to try and solve each problem before going to the answer key. But again, as we talk about, struggle is good, right? Working at things, but when it becomes frustrating and it starts to turn into that unproductive struggle, check out the answer key. Good luck. So for problems 1 and 2, you're finding the area and perimeter. Now remember, the area of a rectangle is length times width. Your length times your width. The area of a triangle is half of a rectangle, so it's half of base times height. Because with a triangle, we replace length times width with base times height. So your base, remember your height is when you climb up to the top of the mountain, drop a rock. So your height is 5. For perimeter, remember you are adding all of the sides. So perimeter equals side 1 plus side 2 plus side 3. And it's the outside, right? So your perimeter is your outside. In this case, it's 4 sides, right? Press pause and solve these problems. When you're finished, hit play and move on to the next. For problems 3 and 4, we're still solving for area and perimeter. So remember 3, this is a parallelogram. And with a parallelogram, it is area equals base times height. So it's like a rectangle, except it's just one that's been blown in the wind, one that tilts over. So remember that your base is right here, right? There's your base, and your height is not, your height is this, right? Climb up the side of the mountain, drop a rock, straight down. That's your height. Don't confuse it with the length of this side, which is 7. You won't use that for area, but you will use it for perimeter. Because again, remember, perimeter is all 4 sides added together. Now 4, remember we talked about this, you need to break it up into shapes to find the area. There's a couple ways you could do this. You could break it up like this and find the area of this rectangle, and this rectangle. Or you could do it like this and find the area of this rectangle, and this rectangle. Now, you notice that here there is no dimension. So how do you find that? Well, what we have is we have our base right there. We've got that side, which is 9 centimeters. And we know this is 4 centimeters and this is 3 centimeters. But this all together is 9 centimeters. So if this whole dimension is 9, and you know 4 and you know 3, which is 7, what's left? What is left is the dimension right there. And again, perimeter is all sides added together. Hit pause and solve these problems. When you've finished, press play and continue on to problem 5. For problems 5 and 6, you are finding the surface area of each figure. So this looks familiar to a figure that you've done in one of your previous problems from problem 4.3. So what you're going to do here is you need to find the area of each one of these shapes. So you need to find the area of this triangle, of this triangle, of this triangle, this triangle, and this rectangle, right? So you've got 5 areas that you're going to add together. But let's look at it. So let's first look at this triangle, right? What is our base? Well, you can count. You can go 1, 2, 3, 4, 5, 6, 7, 8. But what do you notice? That this triangle, all the triangles, sit up against a square, which is 8 units. So each one of these bases is going to be 8. And then climbing to the top of the mountain, dropping the rock, it gives you 7 units for the height. So your area of a triangle is 1/2 base times height, right? And you'll notice that because this is a square, when this net is folded back up, it becomes a pyramid, all right? So we know that each one of these triangles is equal. So you're going to have 4 areas for the triangle. Then you need to solve for the area of the square. Remember, for an area of a square is length times width. Then you add everything together. Hit pause, solve the problem. Once you've finished, go on to the next one. For this problem, you're going to do the same thing. You need to find the surface area of all the faces or all the sides. And when you look at this, does this look familiar to something you've seen before? What will this net fold up into? What you should see is that it folds up into a rectangular prism, right? So it's going to fold up into something like that. And you can see that one side is 20 centimeters, right? And then you know that as this folds up, this folds up. And so your width becomes 9 centimeters. And then when this folds up, your height becomes 5 centimeters. So how does that fit into here? Well, let's look at that. Let's erase these here so we don't confuse you with that. So this is 20 centimeters. If this is 5, we know that when these two fold together, this becomes 5 centimeters. We know this is 9 centimeters. And then we know this is 20 centimeters because it's just as long as this. And then when this folds up to the top, because this one will fold up and become the top, so we know that is 9 centimeters. So we now have all our dimensions. What you need to do is find the area of this, of this, of this, of this, of this, of this, and then you add them together. Hit pause, work on the problem. Once you're done, hit play and move on to the next. So for problem 8, they're asking how many square inches of cardboard is needed to make the micro box. So how many inches of cardboard is needed to make this box? So what you are solving for here is surface area. Now what you need to remember, in a rectangular prism, there is typically 6 faces. But what they say here, there's no top on the box. So do not include the flaps. So you are not including this face. So you only have 5. So you're going to look at the area of, you're going to look at the area of this face, right? And that has a backside. And you're going to look at the area of this face. And that also has a matching side on right here, right? And then you're going to look at the bottom. So you're going to find the area of all those faces and add them together. Now for problems 9 and 10, you're finding the volume of the 2 boxes. And remember from our last problem, when we solved for volume equals length times width times height. And be sure to label your answers. Pause here, solve the problems, and when you're done, hit play and move on to the next problem. So for this problem, you are labeling the coordinates. So let's first do this. We're going to go A, B, C, and D. So you're going to find the coordinates for A, for B, for C, and for D. And remember, when you're listing coordinates, you always do the X first and the Y second. So your X is your vertical, and your X is your horizontal. X is horizontal, and Y is vertical. So what is the coordinate? So let's erase that and get that out of the way so we can see the numbers again. So what is the coordinate for A? So go over on the X, up on the Y, find the coordinate. For B, go over the X, up onto the Y, find the coordinate. Do the same thing for C and D. Pause here, solve the problem. When you're ready to move on, hit play. So for this problem, the things you need to know are that you are making a right triangle, right? So that's critical. Right triangle, and your height is 7 units. So remember the shape of our right triangle, where your height needs to be 7 units. So label that third point wherever you choose to draw it. There are a couple options. Label it C, and then solve for the coordinates, just like you did with problem 11. Hit pause, solve the problem. When you're ready, hit play and move on to the next. For this problem, you need to estimate the area and perimeter. And we call it an estimate because this is not, a square or a triangle. There's no formula for how to solve for this, right? So you can see what we have is a lake. It's irregular shaped. Now we spent some time on this when we first started talking about area and perimeter. You might recall this. There was one with a lake and there was one with a foot. So what you need to do is, like for area, right? A good strategy would be to count the squares. But now you want this estimate to be as close as possible. So think about how you're going to estimate when there isn't a full square there. How will you count that? For the perimeter, it becomes a little bit trickier. You may need to use a ruler, or you may just need to guess based on where the outside of the lake is following compared to the squares on your sheet. So do your best and see what you come up with. Pause here, and once you've completed this, you're done. You can go to the answer key and see how you did.